Welcome back to my channel. In today's video, we are going to complete our snake game project. It's been a fun journey and we're almost at the finish line. In this video, we'll add some final touches, including collision detection, score tracking, and increasing the game's difficulty. Let's dive in and wrap up this project. Alright, let's move on to detecting collisions between the snake's head and body. We're using the turtle module, where each part of the snake is a separate turtle object. Here's how collision detection works. As the snake grows, new segments are added to its body, stored in a list called parts or segments. We loop through each segment and check its distance to the head. If a segment gets within 15 units of the head, we detect a collision and reset the game and score. This ensures the snake can't run into itself. Now let's add collision detection between the snake and the boundaries of the game screen. We've created a border around the screen and the snake should not go beyond it. To detect a boundary collision, we'll check the X and Y coordinates of the snake's head and then copy our previous code. Here's how it works. If the snake's X coordinate exceeds 390 or is less than minus 390, or if the Y coordinate exceeds 390 or is less than minus 390, we register it as a collision. Now that we've added boundary collision detection, let's fix the issue with the score not updating. Here's what we need to do. Update the score, ensure that each time the snake eats food, the score increases and is displayed correctly. Handle food collision. When the snake's head collides with the food, move the food to a new position. Add a new segment to the snake. Increase the score. Update the high score if needed. I've accelerated the process so you don't waste any time. We'll dive into the important variables and functions that set up our snake game. These elements are crucial for managing the game's state, score, and difficulty. Here's a look at the essential parts of our code. Variables, delay equals 0.13. This controls how quickly the snake moves. A smaller value means faster movement. Score equals 0. This keeps track of the player's current score. Level equals 1. This represents the current level of the game. Level threshold equals 100. This determines the score needed to advance to the next level. Speed increment equals 0.05. This is the amount by which the snake's speed increases as the level progresses. Load high score. This function attempts to read the high score from high score txt. If the file isn't found or an error occurs, it returns 0 as a default value. This ensures the game always has a high score to use. Save high score. This function writes the current high score to high score txt. It updates the file each time a new high score is achieved, allowing the game to remember the highest score across sessions. Now that we've set up our basic variables, let's move on to the high score system and how we display it on the screen. First, we have a line in our code that says high score equals load high score. What this does is load the previously saved high score from a file. If the file exists, it reads the high score from it, allowing us to keep track of the player's best performance even after they close and reopen the game. If there's no high score yet or the file doesn't exist, it simply returns 0, so the game always has a valid starting point. Now, let's talk about how we display this high score on the screen. We're using a turtle object called pen. This pen is responsible for updating and showing the score, high score, and level while the game is running. When the game starts, we use the pen to write a message on the screen showing something like score, 0 high score, previous high score level, 1. Every time the player collects food or moves to a new level, we need to update this display. The pen object clears the previous score and rewrites it with the updated values. So, if the player's score increases or they reach a new level, we'll see that reflected instantly on the screen. It's a smooth way to keep track of progress without disrupting the gameplay. The high score also updates if the player beats their previous best. We save this new high score using the save high score function, so it will be remembered the next time the game is played. In summary, the high score is loaded, displayed, and updated using a combination of our load high score function, the pen object for drawing text, and the save high score function to make sure we don't lose the player's progress. With this setup, players can keep track of how well they're doing and aim to beat their best score. Now let's take a closer look at how the score and level are updated in our snake game. Whenever the snake eats a piece of food, the player's score increases. Here's how that works. When the snake's head gets close enough to the food, let's say within 20 units, the game detects that as the snake eating the food. When that happens, we increment the score by 10 points. This is done with the code score plus equals 10. At the same time, the game checks if this new score is higher than the current high score. If it is, we update the high score by setting high score equals score. Now, every time the score changes, we also need to update what's shown on the screen. The pen clear function erases the previous score display, and then pen write redraws the new score, high score, and level on the screen so the player can see their progress in real time. Now, let's talk about leveling up. The level system is tied to a threshold, which in this case is set at level threshold equals 100. This means that for every 100 points the player earns, the game moves to the next level. So when the score divided by the level threshold equals or exceeds the current level, we increase the level with level plus equals 1. As the level increases, the snake's speed also increases to make the game more challenging. This is done by decreasing the delay between each snake. Movement delay equals speed increment, making the snake move faster. To sum up, each time the snake eats food, the score goes up by 10. If the score reaches a certain level threshold, the game advances to the next level, which also speeds up the snake. Both the updated score and level are displayed dynamically on the screen for the player. This adds a fun challenge, keeping the gameplay fresh as the player progresses. Alright, our game is ready to go. If you enjoyed this video, don't forget to hit that like button and subscribe. The code link is in the description, just fork the REPL and make it your own. I'll also be dropping a video on how to use Replit soon, so stay tuned.